I am fine. Yes. I'm ready, Sean. Sorry for the wait. My apologies.
All right. This is a question from Pakistan.
Yes.
I was able to get through most of it, but I'm having trouble figuring out the inflection points. So it is consider the equation below. X to the fourth power minus 50x to the second plus 3.
And we only want the inflection points.
Correct.
Okay. So first of all, I have to find the first derivative because I have to find the second derivative and study it because the second derivative gives us concavity and inflection points. Is this okay so far?
Yes.
Okay, so when I differentiate the first time, I get 4x to the third minus 100x. Is that okay?
Yes.
And then when I differentiate the second time, I have 12x squared minus 100. Is that so okay so far?
Yes.
So now I have to set this equal to 0. So then 12x squared minus 100 equals 0. And then I have x squared equals 100 over 12. And yes, I can simplify by 2. And then I get 50 over 6. I would rather not, because I have plus or minus 10 over 2 the square root of 3. So now this becomes indeed plus or minus 5 over the square root of 3. So in the table, if I only want to look at the second derivative, then I will have negative 5 over the square root of 3 and 5 over the square root of 3. And this is quadratic and it has a minimum. For the study, for the purpose of this, I'm not going to graph this, but I'm graphing it here just to see the sign, the sequence of signs. So this is one solution that is negative and this is the other one. So obviously positive, negative, and positive is the sequence of signs, or just plug in a number. So when it comes to concavity, holds water, it does not, and holds water. Concave upward, downward, upward. So in order to find the points of inflection, I also have to plug them in the function. This in here and this in here. Is this okay so far before I put the function in and put those numbers in?
Yes.
Okay, so in y equals, clear if you have anything, and I punch in the function, x to the fourth, and then I have minus 50x squared, and then I have plus 3, and then I go to second and table. The function is even, so it's sufficient to find this. This will be at the same level, because if you replace x by negative x, so these two have to be the same. So negative 5 divided by the square root of 3, and if you put the positive, you'll get the same thing. So I got negative 344.22. You can plug in 5 divided by the square. You can plug in, you'll get the same answer. Because as I said, the function is even. So you get this, you have to get the same thing. Okay, so the inflection points for this function, I don't know how they want them. So maybe they don't want an approximation. So it's fine if they don't want an approximation because I can determine this. So this will be 5 to the fourth over the square, it's 3 squared, which is 9, and minus 50. So again, I'm doing this one more time because they may want an exact answer. So 25, so 25 times 25, 625 over 9. and minus I don't have something is not right, so let me see. So this is 3 squared, but this is just 3. This here is just 3. They cannot be the same. To the 4th power and the 2nd power cannot be the same. Sorry about that. So plus 3. So now the least common denominator is 9. This needs a 3 and this needs a 9. So I'm going to do this with a calculator. 625, but minus 3 times 1250 and plus 27. So again, I don't know how they want the answer. So 1720. So I can simplify. So these are the points of inflection. One point of inflection is -5 over the square root of 3, comma, -3098 over 9. And then the other one with a plus, identical. So what do you think you missed, or what was the situation?
Maybe it was the answer that I put in, it not being exact. I just did like what the calculator gave me.
But did they want the exact? What did they say in the problem?
It says just find the inflection points, smaller x value, larger x value.
Oh, so they don't want the y value at all. Maybe you put the y value and they don't want it.
Well, in the previous problem, it says find the inflection point. So next to it, it has x comma y equals.
So this one has x comma y?
Yes. So I'll try the answer that you have and see what we got.
Did you get something else here as the x values?
No, that's what I got. I try it like in different forms. Maybe they didn't want.
So I don't know, because if they want something like this, they normally tell you how many decimal digits to use.
Mm-hmm.
So maybe they want this as a fraction. I'm checking my calculations. So 5 to the 4th, 25 squared is 625. 3 squared is indeed 950, yes, and then that's 25 over 3 plus 3.
Yeah, they wanted it in a fraction form.
So did it take it?
It's my fault for being.
That's okay. Did it accept this?
The fraction?
Yeah.
Yes.
So the answer is correct?
Yes.
Okay, perfect. Very good. Next question, please. Anything. If they don't say approximate, then you have to work your way through like that. I'm pretty sure that that's what they want. If they don't say approximate.
Thank you very much.
Thank you. Good. Next question. Anything else we continue with? Anything? Anything else? And I found out why my computer froze and stopped the video the other day. But I caught it on time. Is because I did not delete the videos from the recycle bin, and it didn't have space anymore. That was the problem. But now I delete them from both. Yes. Anything else? Anything else? Have you tried anything else? Is there anything you need me to do? Okay, So, do you think from section 4.3, we had examples with graphing. The entire section 4.5, is only graphing. So we're going to go back to everything again. But I'm more than willing to work on any problem you would like. Or do you think that section 4.3 is accomplished? You consider 4.3, we want to work on another problem from 4.3, or we move on. I need your help to make a decision. What do you need me to do?
I can find either one going over it. Nobody's really saying anything, so.
Yes, so you want me to choose another problem, anything you'd like, or maybe to look at a rational function. We looked at a trig function.
Yes, the polynomial or a trig function. Could we do a rational function?
Yes, so we can do a rational function. So here's a rational function here. Or we can choose another rational function from section 4.5. They're all the same. I'm not teaching you anything new in 4.5. Nothing. We just put everything together like we already did. So rational function, there is one here, there is one here, there is one here, one here, one here. So on page 317, I can let you choose a rational function, or I can choose a rational function. It doesn't matter really.
Try to get the book up now. Here, I guess maybe number 11.
Okay, number 11. Very good. Good pick. So let's look at 11. This comes from page 317. You can say, are we there yet? Well, yes, but not entirely. But for this function, it's not a big deal. Everything we know is what we need. Okay, I'm going to shut this book and put it away because it's terribly heavy. Okay, so here we are asked to graph this function, presenting everything. I'm going to start my table before I continue or do anything here. F prime, f of x, and the second derivative. Then I come back and I realize that I don't like the way this function is presented, which means the numerator and denominator are not in descending order. I see a negative leading coefficient. It needs fixing. So negative x squared plus x will be the correct numerator. And then x squared minus 3x plus 2 will be the correct denominator. In the next step, I will factor out negative x. And I will try to see if I can factor fully the denominator. It happens that the denominator is factorable into x minus 1 and x minus 2. And the numerator, when I pull out x, I get x minus 1. So I prepped the function for a lot of things. For domain, for x-intercepts, y-intercept. So finding the...
Excuse me?
Yes.
Numerator?
Yes.
Shouldn't that be if you pull out a negative x? Oh, wait. Oh, no, that's it. Yeah.
That's okay.
Okay.
That's fine. You know, sometimes I make mistakes myself, so I'd rather you stop me and let me go back and see if that everything is okay. Perfect. Is this okay, everyone? Perfect. Okay, so the next step is obviously the domain. Don't touch it. I know you see that you can simplify x minus 1. Don't touch it yet. So the domain is obviously everything except 1 and 2. If the function is undefined at 1, so is the first and so is the second derivative. Now I go back, after I stated the domain, I can go back and simplify. And the simplified form is negative x over x minus 2. Here's what happens. The factor that went away, x equals 1 from the top in the numerator, x equals 1 will become a hole in the graph. The factor that still stays in the denominator, x equals 2, will be a vertical asymptote. I'm going to copy the simplified form of the function here so I can put this away. So it's negative x over x minus 2. I know that, so what I'm doing right now, I'm trying to fill out the chart. First, I have to study this function as much as I can. X and y intercepts and behavior, everything, asymptotes. And then, only then, I go to the first derivative, and then I go to the second derivative. Okay. So when we talk about x equals 2 being a vertical asymptote, I will immediately put the infinities next, left and right. But I don't know the sign. I use these points as close as I can to 2, but I will not consider them in the table. I'm not going to do anything else with them, but just study the sign. When I plug in 1.9, the numerator is positive, but the denominator is negative, but there is a minus in front. So I see 2 negatives. With 2.1, the numerator is positive, the denominator is positive, but there is a negative outside. Now, with 1, I have to plug in 1 in the simplified form. It's not going to be undefined, because I already removed the factor that creates it indeterminate, actually. 1 minus 2 is negative 1. 1 over negative 1, negative 1 minus 1, positive 1 on both sides. So then the whole will be 1 comma 1. 1 comma 1 must be a whole. I have to plug in 0. 0 over negative 2, that's 0. And I have one more item to fill in, this, which means the limit as x approaches negative infinity from the function, and the limit as x approaches infinity from the function. And I'm done with this. There's nothing else I can find about the function from the function itself, just these two limits. I found the limits here, I found the whole, I found the x-intercept. There is no y-intercept. X and y-intercept are the same. There is no extra x-intercept, I meant to say. So, but now I need to find the limit. So, limit as x approaches negative infinity from negative x over x minus 2. I know this is infinity over infinity. I like it because I know L'Hopital's rule. When I differentiate the numerator, I get negative 1. When I differentiate the denominator, I get 1. So the answer is negative 1. That means y equals negative 1 is a horizontal asymptote. There is no need to calculate the other one. Even if you do, you will still get negative 1 because it's a rational function. So this is negative 1. This is negative 1. So y equals negative 1 horizontal asymptote. So now all this is completely finished. I'm ready now to go to the first derivative. Any questions before we continue with the first derivative? Any questions? Questions? Okay. I put a video but I actually put them in both anyway. In both classes, but I put all of them in one class for now. Okay. I have to do this in parallel so I don't, it doesn't cut me off and does not record. Okay, so we're ready now to find the first derivative. The negative stays outside. Remember, this is a quotient. We have to use the quotient rule. The top prime is 1 times the denominator minus the top times the denominator prime, which happens to be 1, over x minus 2 squared. Do not be tempted, please. Don't be tempted, please. Okay, so negative x minus 2 minus x, these two go away, over x minus 2 squared. The minus with minus in front, 2 over x minus 2 squared. I love it. It's always positive, never 0. So, no critical numbers. And since it's always positive, what does that mean about the function? When the first derivative is always positive, what does that mean about the function? What does it say?
Always increasing.
Always increasing. Very good. Very good. Perfect. Part 2. 13. Okay. Perfect. So now, at this point, I have to make sure that these two work well together. That's the moment I normally catch my mistakes. Okay, so let's see. From negative 1 to 0, what does the function do? It increases, and so it's supported, that is supported by the sign of the first derivative. From 0 to 1, also increasing. From 1 to infinity, also increasing. From negative infinity to negative 1, also increasing. These two work well together. Now I have to find the second derivative. The first derivative is 2 times x minus 2 to negative 2. This is what I am going to differentiate. So the second derivative is negative 4, x minus 2 to negative 3, times the inner function prime, and that's 1. Never 0, but don't be fooled, because x minus 2 is not raised to an even power. So for the sign, for the purpose of the sign, I'm going to write this. I'm only trying to study the sign because I have to fill in it here in the table. I know there are no inflection points. There is no discussion there because this is never 0. The second derivative is never 0, so there are no inflection points. But I have to study the sign, but I will not study the sign of this piece because that piece is always positive. So the sign will only be given by negative x minus 2. So it's 0 at 2. To the left-hand side must be positive. Plug in any number to the left-hand side of 2. Because this negative x plus 2 is a linear function with a negative slope. It's coming from positive going to negative. At 2, it changes. But there is no point. If I don't have a point, even if it changes sign, if I don't have the point, the function doesn't have an inflection point. But I know that it holds water, and it does not. So if anyone is asking you what are the intervals of concavity, you will say opening upward between negative infinity and 2, opening downward between 2 and infinity. In this interval, there is no critical number, so there is no minimum. In this interval, there is no critical number, so there is no maximum. And now the question is really asking us to get all the information and graph. There is one thing that does not fit in my table, which is symmetry. So symmetry, remember, f of negative x can be equal to f of x, which means even, or it can be negative f of x, which means odd. Well, a function with a hole in the graph at 1 and a vertical asymptote at 2 cannot have any symmetry. But I have to mention and say not symmetric, because it's one of the items on the list. Okay, so let me see, where is the time here? Okay,